Calculus! We are in AP Calculus, self-check 6.3. We are doing 2010 number 6. So the equation of the line tangent, so immediately when you do this one, you should be starting out by writing y minus that y1 is equal to the slope times x minus x1. And they give you x and they give you y, so x is 1, y is 2, so you can immediately plug in those values. X is 1, y is 2, but we don't have the slope. Luckily they give us y prime here. This is the same thing as y prime. So we just need to plug in 1 and 2 into this equation. When I plug in 1 here and 2 here, that's going to be 2 to the power 3, which is 8. 8 times 1 is 8, so the slope here is 8, and then I get my point. So let's go ahead and look at the solution guide. So I need to take f prime of 1, so if you have 8, give yourself plus 1. If you have the rest of the equation, y minus 2 and x minus 1, the rest of that, those two here and here will give you another plus 1. So that was out of 2 for A. How many points did you get out of 2? You can put it on the left, that way it's easier to tally up at the very end. If you simplify it, yep, as long as you simplified it correct, then you're good. If you simplified it incorrectly, then it's not okay. So did you go, I'm guessing you probably went y is equal to 8x minus 8 plus 2 minus 6? Yep, if you did that, you still get your point. If you have this exactly, that's 2 out of 2. Any questions on the scoring for part A?
What if I had like the point slope form, like that initial form, y minus 2 equals 8 times quantity x minus 1?
If you just have that, that's 2 points, 2 out of 2. Yep. They don't care what form it's in. They just care that you have the equation correct and that you have the slope as part of the equation correct. All right. From there, we're going on to part B. So we need to approximate f of 1.1. So we're using this equation. I like this equation better because I can see exactly what's happening. So I'm going to plug in. I have y minus 2 is equal to that 8 times the quantity of. Now I'm plugging in 1.1. 1.1 minus 1. Well, 1.1 minus 1 is just 0.1. 0.1 times 8 is 0.8. So this is now going to be y is equal to 0.8 plus 2, because I have to add 2 to both sides, so 2.8. So let's see, how many points do we get for that? If you get that approximation of 2.8, give yourself plus 1. That's plus 1 right there. And by the way, all of part B is out of 2 points, so give yourself out of 2 over here. So that's the plus 1. And then I have to check that whether or not if it's an over approximation or an under approximation. It gives us kind of this useless information that the height is always, I should do this in blue, that the height is always greater than 0, which we can assume because we know that at 1 it's positive, at 1.1 it's 2.8. So they give us kind of useless information that the height is always positive, but they do want to just give you that. But the thing that you need to check if it's an under approximation or an over approximation is what?
Concavity.
Concavity, exactly. And they give you the second derivative. They give you,
I totally forgot to do that.
They give you y double prime right here. So we have to check when we plug in 1, 2, when we plug in that value to this, is it positive or negative? Is it concave up or concave down? So let's go ahead and do that. Y double prime of 1, 2 is equal to, and when I plug in 2 to y cubed, that's going to give me 8. So that's my y cubed times 1 plus 3 times, I'm plugging in 1 into x squared, so that's just 1, don't worry about it. And I'm plugging in 2 into y to the second, so that's going to be times 4. 3 times 4 is 12. 12 plus 1 is 13. 13 times 8. Okay, we don't actually need to calculate that. We just know that is greater than 0. That's all we need to know. Is it concave up? Is it concave down? That is clearly concave up. All right, so if we know that it's concave up, you also kind of need to know that it's positive height. But mainly, it's concave up. Is that an over approximation or an under approximation? What do we think? If it's concave up, so this is, you can do a little graph, that's where we practice our graphs. If I have some point out here, and I use this tangent line, but if it was concave up, maybe I should do that in blue. Concave up, come on now. This blue function is the actual function. We found that point. Is that point above or beneath the actual blue line?
Below it.
It's below it, so it's an under approximation. So here's our answer. 2.8 is under approximation. And you need the reasoning because f double prime is greater than 0. You have to have that. This fact and this fact, under approximation and f double prime greater than 0, those two together will give you plus 1. So how many out of 2 did you get on the left? Go ahead and write it. What is your score? And then we're on to part C. Find the particular solution. So this is where all of our points come from. So separate. Separate. So first I need to cross multiply. My original multiplication is here. dy times 1. So I have 1 dy, or just dy by itself. And I have xy cubed dx. Xy cubed dx. And then from here I need to actually separate them. I'm going to divide both sides by y cubed, and I get 1 over y cubed dy is equal to x dx. I'm done with my separate. Now I go on to my integrate. When I integrate both sides, I am going to integrate y to the power of negative 3 dy, and I'm going to integrate x dx. Again, I don't like fractions, so I immediately turn it into a negative power. When I integrate y to the negative 3, I get y to the negative 2, because I go up a power. When I go up a power, then I divide down, divide by negative 2, and that's going to be equal to, I go up a power, x to the power, it was 1, it's 2, and it's divided by 2. Don't forget your plus c. How many points did we just get just doing those steps right here? So separation of variables. If you are able to separate by this step, you give yourself 1 point. Let's come back to the solution guide. If you took the antiderivative of the left and the right correctly, give yourself 1 point, plus 1 point. What did you get?
I got negative 1 over 2y to the positive 2.
That's perfect. Yep, that's the correct antiderivative. You just switched the negative power into the denominator, made it a positive power, right? Yep, that's perfect. I'm going to do that in the next step. You're ahead of me. And then if you got your constant of integration, if you wrote plus c, give yourself another plus 1. By the way, how many points is this problem out of? This point, it's all out of 5 to add up to 9. So this is out of 5. All right, so far we have 3 out of 5 possibly. We are now on to evaluate. You do want to do evaluate before or isolate in this case. So evaluate, I'm plugging in x, I'm plugging in y. Y is 2, x is 1. So I'm going to rewrite this just like Rochelle did. This is now going to be 1 over negative 2 times y squared. And instead of saying y squared, I'm saying 2 squared. And now that's going to be equal to, and I'm going to plug in 1 for x, so that's going to be 1 squared over 2. Thank you, Kaylin. I am recording the video. Plus c. And then I'm going to simplify this. 2 squared is 4 times negative 2 is negative 8. So 1 over negative 8, that's going to be equal to 1/2 plus c. Subtract 1/2 from both sides, which is the same thing as subtracting 4/8. So I have negative 5/8 is equal to my c. All right. And just by using initial conditions, as soon as you plug them in, oh, what just happened? I don't know what my computer's doing. There it goes. As soon as you plug in these values on the AP test, give yourself 1 point. If you're able to boil it down to c equals negative 5/8, in my class, that's where I'm going to give you the plus 1. On the AP test, they would have given you the plus 1 right here. And then finally, if you want to do the optional isolate step, I'm going to do that down here since I ran out of room. The optional isolate step, I would need to get y by itself. So I'm coming back to this form where I have 1 over negative 2y squared is equal to x squared over 2. And instead of saying plus c, I'm going to say minus 5/8. Minus 5/8. And then I need to isolate. So I want to take the reciprocal of both sides, but I can't take the reciprocal of this entire side until I make it one fraction. So I'm going to make it one fraction by multiplying the top and bottom here by 4 and by 4. So now this new fraction is going to become 4x squared minus 5, all of that over 8. Now it's one fraction. I can take the reciprocal of both sides. When I do that, when I take the reciprocal of both sides, I get negative 2y squared is equal to 8 over the quantity of 4x squared minus 5. Now I just need to solve for my y. So when I do that, I'm going to come back up here, just using arrows to follow my work. Then I'm going to, yes.
How did you get negative 2 to the positive 2?
So I took the reciprocal of both sides. I flipped these two, so it's negative 2y squared over 1, and I flipped these two. So it's now 8 over 4x squared minus 5. Yeah, you're allowed to take the reciprocal of both sides, as long as you have no domain problems, and we don't have any domain problems in this one. So we take the reciprocal of both sides, and then from there, I'm going to divide both sides by -2. So that will get me, we'll stay with black. So I have y squared is now equal to 8 over the quantity of negative 8x squared plus 10. I just put that -2 in the denominator and distributed the -2. We're okay with that step. All right, and then from there I have to square root both sides, and I get my final answer, well, almost final answer, of y equals plus or minus the square root of all of that, 8 over negative 8x squared plus 10. And then I have to figure out if it's a plus or a minus. In this case, let's go ahead and plug in our initial conditions. X is 1, so negative 8 plus 10, that's going to be 2. 8 divided by 2 is 4. Square root of 4 is 2, and I had 2 on the left, so 2 needs to be matched with positive 2. So the correct answer is the positive version, not the negative answer. All of that will give you plus 1. So if you did all of this extra work, which is optional, that will give you another plus 1. So if you get this answer right here, that is your plus 1. How many points did you get out of 5 for that problem? And then at the very top, how many points did you get out of 9? Tally them up. All right, Rochelle, how many did you get?
7.
Whoa, nice. Jeez. Arrow, how many did you get?
No points whatsoever.
No. Oh no. What happened?
I didn't read the directions.
Oh, okay. And what about the step C?
It was so messed up by the time I got to see that I liked it.
Yeah, that's hard. Yeah, and that's what would happen on the AP test too. You get 0, but you learn that now, and then you're gonna be better in the next one, right? Ben, how many did you get?
Probably like 6 or 7.
You didn't even
6
have
or
it.
7? What have you been doing in the past 2 minutes?
So on the, well, like it's totally different. My y equals, the final isolated form is like different from theirs, but it seems like it might be equivalent except for one sign problem, so it's probably not. But it's like totally different. So I don't know how they got to what they have.
Okay. I can come check that on my right after you're working on this. By the way, yesterday we talked about the cell check 6.1 where I wasn't sure why we needed the domain. Remember on this one we had to have a domain where x was less than 0? Do you remember that? Here's the reason why. Look at the initial condition. The initial condition, where is it? Yeah, so whenever you have an absolute value, you will have one of 2 options. You have to have the domain. The first option is x is greater than 0. The second option is x is less than 0. Both those answers stem from where is your initial condition. That's as simple as it gets. Yep.
So you have to have the domain.
You have to have the domain whenever you have an absolute value. Yep.
But there wasn't this time.
There wasn't any absolute value in this last question, no. All right. So if there are any more questions, I can come answer it while you're working on self-check 6.4. Go ahead and put that away. I'm going to pass out 6.4 and we'll have 10 more minutes to do